So the next topic we will talk about is boundary value problem. Okay, boundary value problem, and we can call it BVP. Okay, and we will first introduce what is the difference between the IVP and BVP, the initial value problem and the boundary value problem. Then we will show different type of the boundary value problem, and let's have a motivation example for the boundary value problem. Okay, so for nth order ODE or first order ODE, you know they can be transferred to each other. For the IVP, that means n condition are given at a single point. And this point is usually the initial point. So for nth order ODE or n first order ODE, for initial value problem, those n conditions to make sure that n arbitrary constant in the homogeneous solution are given at one single point, which is usually the initial point. But for the BVP, that n condition are given at two or more points. Okay, so that is the big difference between the BVP and the IVP. For the boundary value problem, they are giving at two or more points, and it doesn't necessarily need to be at the initial point. The following lecture will focus on non-homogeneous BVP, and we will solve it numerically. Okay, we will solve it numerically. How we solve that numerically? One method is called shooting method. The other is called finite difference method. And for each method, we will take detailed explanation. What is shooting method? What is the finite difference method? For shooting method, here we can just briefly say that is an iterative method. And for the finite difference method, that FD is basically convert ODE to algebra equations. And then we will have a one balance equations for each finite volume or finite node, and for with one balance equations for each finite volume or node. Okay, and for shooting the finite difference method is especially good for the multi-dimension and the multi-scale models. Okay, we will talk each examples for shooting method and finite difference method later. Okay, that is boundary value problem. We will have the general notations for the boundary value problem. So the general notation of BVPs. We will have nth order ODE and we will specify n conditions. Okay, so what you can have is, for example, y at point 1 have a value k1, y at point 2 have another value, until y at point n has kn value. Of course, that is a extreme case for n's condition. You have n points offering that conditions. Where those P1, P2, until Pn are the boundary points for nth order ODE. And you know those conditions are particularly solving those homogeneous solutions with that n arbitrary constant, right? More often, we are now passing n conditions through n points. We are passing 2 points. So two boundary points, P1 and P2. So that n conditions are coming from n1 conditions at P1 and n2 conditions at P2, where this n1 plus n2 will be equals to n. So in total, you need to offer n conditions passing 2 different points. And that is usually the case for our boundary value problem. The general form for the boundary value problem is B, J, P1, Z equals 0 for J equals 1, 2 until N1, BK, P2, Z equals 0 for J equals 2, 1, 2, until N2. So basically the boundary conditions at P1 for this ODE are passing this, are having this N1 conditions. Then at point 2, it has N2 conditions. In total, it should have N conditions for nth order ODE, where UZ will be equals to Y, Y prime, Y double prime until Yn minus 1 prime. Okay, that is for our ODE. You can also say for, let's make an example for second order ODE. Okay, for second order ODE, you can represent that P1. So you have second order, you have Y and Y prime. That is equals to A1 Y P1 plus B1 Y prime P1 minus W1 equals to 0. B P2 Y Y prime equals to A2 Y P2 plus B2 Y P2 prime minus W2 equals to 0. Okay, so that is examples for second order ODE's general form with boundary value problem. Means that at one condition, it passed by P1 with the condition Y and Y prime at P1. Okay, at second point, you have YP2 and Y prime P2, and that is passing the second point. So with these two boundary conditions, you can solve what is your arbitrary constant in your homogeneous solutions. Okay, so that is the general notations for boundary value problem. And boundary value problem, it really depends on how you give the boundary conditions. Then we can define 3 different types of boundary value problem. So the first different type, we'll say different type of boundary value problem. Okay, and that is depending on how you give the boundary conditions. For example, we have dirichlet boundary conditions, where all the boundary conditions y prime, you are giving y. So it's only past the point. For example, you have these boundary conditions at x1 equals to what? X2 equals to what? Okay, so that is only giving the boundary condition of y. There is another called Newman boundary conditions, and that is instead of giving the boundary condition at y, you give the boundary conditions at y prime. So for example, x1 prime equals to what? X2 prime equals to what? Then you have the third type is called Robin boundary conditions. Then you are giving the mix of y and y prime. Okay, so that differentiates what is the type of the boundary value problem, and we will solve it differently for the boundary value problem using the Suking method and the finite difference method. And next, we will give examples about boundary value problem.